interesting news out of Alaska. I've said it in my last update video. I think if you have such a magnitude of an earthquake, magnitude 7.0, right beneath a massive mountain with a glacier, that should have an effect on the glacier. And we know now that it did. And guys, it's massive. So it was a good weather situation. So the Yukon Geological Survey decided on Friday, December 12th, to take advantage of this weather window, and they flew to the site of the Hubbard Glacier earthquake that happened on December 6th. Before I show you the images of what really happened, let's just quickly look at that fault again so that we really understand what has happened here. So it was not directly happening on a single well-mapped major fault like the Denali Fault that is close by or the Fairweather Fault, but it rather appears to have ruptured along a previously unconfirmed, and that's interesting, or connective structure, how we could call it, between the Denali and the Fairweather Fault in southeast Alaska. So what currently is the up-to-date knowledge, what scientists understand, the quake struck in the St. Elias Mountains area that is beneath the Hubbard Glacier. That's about 55 miles, 90 kilometers north of Yakutat in Alaska. They felt the earthquake, of course. So that is, guys, a complex tectonic collision zone. Basically, our friend, the Pacific Plate, is part of that Pacific Ring of Fire, guys. Pacific Plate interacts with the North American Plate and the Yakutat microplate that is in this area. So the epicenter basically was happening close to the northernmost tip of the Fairweather Fault. That is a mapped fault. It's a major right lateral strike slip structure that is basically the continuation of the big and dangerous Queen Charlotte Fault system that's a little bit offshore. And we're talking about strike slip. They often call it like the San Andreas Fault of the North. And guys, maybe you remember the video in Myanmar where the land has shifted. That was a strike slip. I'll show you the video again, and you have to probably rewatch it multiple times until you find what I'm talking about, because there's a lot happening. The ground is cracking, the gate is opening, a tower is falling over, but then you have to look at the right spot, and then you see the land move. Basically, if you stand here, your friend is here, they shift. And guys, we have now evidence that the same thing has happened here underneath the mountain, underneath the glacier. So of course the pressing question is, can we see this? What did this do? I'm talking like landslides, avalanches, and can we see the rupture? That is the big question. So the epicenter is not really at a documented fault line. It also lies near the logic footprint of the Tochunda Denali fault system that's a little bit to the northeast. But the precise fault that ruptured on December 6th is not a well-defined single named fault. It's just not. Instead, if we look at the earthquake location and the locations of the aftershock pattern, it's lining up along a proposed connector fault that has been hypothesized for quite a while to link the Fairweather and the Tochunda systems beneath heavy glacial ice. And we know that faults can trigger each other. So that's important knowledge. So the emergent feature labeled by some researchers as the connector fault may represent, guys, a structural link between these major mapped faults in this very remote region. So that's why it took scientists a while to get out there, because it's not safe. You don't know how safe the surface is there, right? So preliminary source mechanisms indicate that the quake was an oblique slip event, meaning it involved both a horizontal strike slip motion and some compressional or thrust components, right? That is consistent with the complex tectonic regime of the Gulf of Alaska shear zone. So what happened actually? And that's really interesting, guys. They flew to the site, and of course, they wanted to document what has happened. Landslide, avalanche activity triggered by that earthquake. And they already had satellite observation that was showing this. And now they wanted confirmation. And very, very important, they went out there to determine whether the fault ruptured the ground surface. Can you see it like it happened in Myanmar? Because this information would be very, very helpful to improve location precision of the fault and of the earthquake, of course, and the strength of the shaking. Of course, it helps to evaluate in the end public safety, especially in this area. I mean, it's not highly densely populated there, but there's a lot of mountaineering, skiing activities in the area. And here it comes, guys. Listen to this. The strike slip was significant. It was a 2 meter of fault slip. 2 meters, 2 large step, roughly 7 feet, occurring at a depth of 5 kilometers, roughly 3.4 miles. So it did do that, what you just saw in Myanmar. It would be amazing to see something that's visible, but this is a glacier, it's covered in ice. But did the glacier crack? They did not find clear evidence that the Earth's surface had ruptured during this earthquake, but it could be hidden by glacier ice. So the rupture was definitely taking place deep down at 3.4 miles, but did you see the surface crack? That's the problem. You can't see the surface, it's full of ice. But the earthquake has triggered numerous large landslides, and the majority of these landslides were on the slopes of Mount King George. That is a 3,741 meter tall peak that is roughly 40 kilometers, roughly like 32 miles east of Mount Logan. So many of these landslides that they could document showed ongoing signs of instability. They were still unstable, which makes sense, right? And when the crew arrived in this area, there were clouds of dust in the air from another large landslide that has just occurred on the east side of Mount King George. And they also observed smaller landslides that had just occurred on the slopes, for example, of Mount Vancouver and Mount Logan and the surrounding sub-peaks of these mountains. What is also interesting, if you go further away from the epicenter, snow and ice avalanches were more common in these areas. So preliminary estimates place the location of maximum slip from that earthquake, as well as most of the aftershocks beneath or immediately adjacent to Mount King George, and the distribution of the largest landslides, of course, logically, therefore, appears to reflect where shaking could have been most intense. But also, in addition to these landslides, the magnitude 7.0 earthquake and the aftershock has also caused another widespread damage to the glacial ice. Well, if you shake that ice, right? Serkas and ice faults were commonly broken up and were toppled by shaking. And it's fortunate that this event did not occur during the mountaineering season, because that would have been highly, highly dangerous. Because if you have like these earthquake triggered serrat faults and avalanches, they have caused fatalities in the past. They have been very, very bad. And the damage to the ice in this region, and also the persistent rockfall from landslide scars that are there now, may pose additional hazards for mountaineering and skiing expeditions in the area. So if that's on your list, be very, very careful, guys. Now mountainsides are exposed, and that could trigger even more. I hope you like this update, guys. Please like and hype this video. If you're interested in stuff like this, California, there's stuff going on. Check the video in the end screen, or 3i Atlas, mystery after mystery. Thanks for watching, guys. Stay safe, be prepared. Click here, I'll see you in a second.